sim. So today we are going to simulate some logical circuits, and logical components. So let's take and or elements. Okay. So we'll also need some switch components. Basic category. Yeah, switch. So let's take four of them. And we also need two new components which we haven't used before. They are logic analyzer and word generator. Both could be found in simulate instruments. Here is word generator and here is logic analyzer. Okay, so let's connect switches. Yeah, so one per one element. So just a few comments here. For this and also for upcoming clubs, I'm not going to explain everything in detail as I used to do in previous lab. So I'll give you some, let's say, general guidance how this could be done, what should be done, also some hints, let's say, and it's up to you to think about, maybe experiment and to find out how this could be done. so let's connect these logical elements to our logic analyzer input ports. Okay, so as you see, yeah, some words about it. So as you see, it has 16 inputs. Yeah, so we will also set some parameters before we can use it as we need. And now this word generator, a few words about it. So as you see, it also has 32 outputs. So this word generator, as it is generator, it doesn't have any inputs, just outputs. So these zeros represent the signal coming from each output. So for example, we set this to 0, 0, 0, 1. It means that from input ports number 0, 1 and 2 will have zeros, and from input port number 3 we'll have 1. So as a reminder, all numeration begins with 0, not from 1. Okay, so in this lab we are going to use only one input signal, 1, 0. Okay, let's set it to decimal, I believe. So 1, 0, 1, 0, 0, 1, 0, 1, 0, 1. Okay, that's enough. Let's set here a final point. So okay, so we'll have such cycle being generated by our word generator 1, 0, 1, 0, 1, 0. So the main goal is to see the signal, how it will be, let's say, processed by these logical elements, and what will be the output, that is input for this logical analyzer. But before I can continue, so the frequency with which this cycle will be generated is 1 kilohertz, as you see here. So we need to set here something as well. So let's set this clocks per division to 16. So we will see 16 cycles on this logical analyzer by one screen. And also here, let's set this. So for some reasons I will explain you later during our classes, we need the clock rate to be the 2 power n of initial frequency of board generator. Okay. So as a reminder, we have only output from our first input, that is from 0 input. So we need to connect it. So to simplify, let's suppose that all signals. Yeah. So let's suppose that this signal will be input signal for all these switches. Okay, let's do like that. So as you can probably predict, if we are using such setup, so for example for AND, so both keys are enabled. That means that here we have 1 and 1 as input. So as you probably might think that output should be also 1 here, and or for our logical element we have input 0, 1, and this also will result in 1 as output. Okay. So if you're ready, yeah, okay, yeah, let's pause here. Okay. So as you see, so here clock internal, that's clock frequency. So this is needed by logical analyzer to synchronize the, let's say, time moments when it's measure the level of input signals. So this clock could be external, could be internal. So we are using internal. Yeah. So here you can also set this clock to be external, but that's not needed. So as you see, for a half of period, both these signals has high level, yeah, and for half of period they have negative. The reason is that for one period we have 1 for 1 0, 1 0 1 0 and so on. So let's now open the switch. So for this element, now the input is 0 1. For AND element, that means the other output should be 0 as well. So as you see, it's connected to the first input. So here we should now have not 1 0 1 0, but constant 0. Yeah. So now as you see, so for all period the output signal for AND is 0. So now let's experiment a bit. So let's say here we also have 1 1 0 0 0 1 1 1. Okay. And let's see how this will change. Okay, let's go. Yeah. So as you see now, as we have 1 1 1 for more than one period. So by the way, just to remind you, we set the clock rate to 16. That means that there are 16 periods here. 1 2 3 4 5 blah blah blah. So this is one period. So here actually we can see that for 3 task for you would be, so first of all, so for this circuit, just modify it in such a way that we will use two outputs. So for example 0 and 1. So I'll just show you a hint how I want this to look like. Yeah, let it be. So 0 output forward generator is input here and here for these two switches, and 1 should be input for this and this. And your first task is to modify this word generator using the same amount of words. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9 words. But as you might now think, that we need to modify two last bits. So not, yeah. So your task is, let's say it would be 10. It would be, yes, 10. Okay, like 10. So for a half of period, we'll have only 1, 1. So here 1, 1, 1, 1. And for the second half, you can set these two bits as you wish. And just experimenting with these switches, try to see what happens here. So try to analyze the logic and also make some screenshots. That would be your first task. The second task would be, so these logical elements are from MOOC Digital and TIL. So we have used OR and also AND. So the digit here represent the number of inputs. So your task is now also experiment with NOR. Okay, let it be NAND and also XOR, if it is here. Not sure. Okay, let's take NOR and NAND. So your task here is perform the same actions used in the first part of this lab, respectively the part what I showed you, but also using these elements. So to sum up, your first task is to modify this word generator to use these two outputs. So the length of cycle should be 10 words. So this one string is called word. That's why it's word generator. So it's word. To use two different outputs to play, let's say, with this logical generator and switches. So please also show some screenshots with settings of your word generator and also logic analyzer. That would be the first part, and the second part would be to replace these two elements AND and OR with NOR and NAND, and do the same. So as usual, you will have 2 weeks to submit your report. So you can do it at home, you can come and do this in class. So anyway, if you have any questions, feel free to contact me via email. I'll answer your questions. And at the beginning of the next week, that is 1 week after this moment, I'll send you a sample report. So how it should look this lab is supposed to be done by students who are enrolled to the course Digital Electronics and Computer Architecture. Okay, so thank you for watching and see you next time. Bye bye.